Okay, after studying first order high pass filter, now we will move on to second order Butterworth high pass filter. Second order Butterworth high pass filter. So now we want the order of filter 2. So what do you mean by order of filter? Order of filter is nothing but the roll off rate at stop band. Okay, so at stop band, how the roll off, the gain roll off, how it changes. So that is decided by the order. In first order, the pass band, we have seen the first order, the pass band region, the roll off was 20 dB. Now if you want 40 dB per decade in the pass band, sorry, in the stop band region, then we have to use a second order Butterworth filter. So how we can get a second order? By using 2 RC stage. By using 2 RC stage, you can achieve a second order filter. But in the Butterworth filter, two things you have to observe. One is we will use positive feedback. Otherwise what happens if you do not use positive feedback? Simply if you use 2 RC stage, your pass band gain response will not be flat. Your pass band gain response will be very sluggish. So if you want to get the response of a first order filter in the pass band region, so that means, so we know that when we plot in actually this is a approximation, actually it will be like this. So at the cutoff frequency you will get minus 7.7 times the maximum you will get. So if you want that kind of a response for second order also, you should use positive feedback. But roll off rate, we don't want a 20 dB, we want 40 dB roll. This roll off will be 40 dB. But pass band, you should always remember two terminologies. One is pass band, this is pass band for this, so where it allow frequency, and this one is nothing but stop band, where it will not give any gain, it is a stop band. So wherever gain is there, that is pass band and stop band. So this is stop band, your roll off rate is decided by the filter. So that's why you have to use, one thing is the positive feedback, another one, the gain should be 1.586, exactly 1 plus RF by R1, that is a gain of non-inverting, sorry, this gain of a non-inverting amplifier, that should be 1 plus RF by R1, that should be 1.586. This value is very crucial. So if you here, since you are using positive feedback, you should be careful, because if you apply too much gain here, the circuit will oscillate. So we don't want our filter circuit to act like a oscillator. For that, the gain should be controlled. So gain is nothing but 1.586 only you have to give. If you change the gain, then response will be different. Okay, so it has to be 1.586, then only you will get this kind of a response. You will get this. That's why this 1.586 gain, if you have, that filter is called Butterworth filter. If you change this gain, then it will be a different filter. For example, if you take more than 1.56, nearly 2, if you take the gain, it will behave like a Chebyshev filter. The filter will be different, response will be different. So we don't want that, we want only the flat response like this, and in the roll off rate should be at 40 dB. For that you have to use this circuit. One is positive feedback, observe, you have to give positive feedback here, not at the first one, at the second R resistor you have to give, and your gain should be this. This is the two constant. So the design is straightforward here. For example, one problem we will take. So let us take this problem, design Butterworth second order HPF high pass filter with a cutoff frequency, 1 kilohertz. So what you have to do here? First one is FL is given 1 kilohertz. You have to select a C. This one you have to select C equal to Again, one more point you have to observe, I have not mentioned, I have not given the cutoff frequency here. What is the cutoff frequency? Cutoff frequency will be given by FL is nothing but 1 by 2 pi square root of R2 R3 and C2 C3. This is what you get the cutoff frequency. Suppose if you take R1 R2 equal to R3 equal to R if you take, and C2 equal to C3 equal to C if you take, then your cutoff frequency will be 1 by FL 1 by 2 pi RC. It is same as the first order. You will get this cutoff frequency. So for this cutoff frequency we have to select C. Let us select C is equal to C2 equal to C3, and we will take a value less than 1 microfarad. So I will take this value. Okay, so always select a value which is less than 1 microfarad. That is what the practice. Okay, so you take that value, then your R will be, so R is nothing but R2 and R3 same value we will take, then this will be 1 by FL 2 pi C. So that value you can calculate 1 by 2 pi 1000 into C is 0.047 into 10 power minus 6. If you do that, you will get a value equal to 33 kilo ohm. So you will get resistor value 33 kilo ohm. Capacitor value we have selected. Now gain is fixed here. So AF should be 1.586. There is no option here. We have to take 1.586 only. Now 1 plus RF by R1, that is equal to 1.586. So that gives RF by R1 equal to 0.586. So if R1 you have to select R1 10 kilo ohm, then your RF will be, it will be 0.586 times R1. This will be nothing but, if you multiply, this will be 5.86 kilo ohm. That only you will get. Okay, so and this is what we designed, because we design means here we should know the value of C2, C3, R2, R3. That we have seen. We have taken C2 equal to C3 and R2 equal to R3. That value we have found, and R1 and RF, that value also we have found, R1 and RF also. And magnitude, you want to plot the magnitude, that one you have to see here. Magnitude will be, so that V0 by V in magnitude, if you, that is not asked in the question, but I am just giving, magnitude will be, it is nothing but AF divided by 1 plus FL by it will be FL by F. So this variation you have to observe, FL by F to the power of 4 under the square root. This is what you get. So the gain is AF divided by FL by F to the power of 4. This is one you have to observe. Just let me see here, what is the gain response you have taken here. So in the one change you have to observe, that is, it is in the gain, it is FL by F. So in the first order we took, just see that first order it is it was F by FL, it was the gain expression was this, and for the second order it will be FL by F. This one you have to be careful. So this you can obtain from the derivation. So the derivation is not included in the syllabus, so you can directly take, it is FL by F to the power of 4. Okay, thank you.